Okay, so in this video, I'm going to go over how you define a plane. So in general, what we're going to do is we're going to define a plane to be, basically it's a very thin sheet of paper. You could think of it that way in space, a very thin two-dimensional sheet in three-dimensional space. So we're going to define point 1. Hold on just a second. Okay, so we're going to define point 1 to be x1, y1, z1, and the point will be x, y, and z. So we can find a vector using these 2 points. So p1p is equal to head minus tail. So x minus x1, y minus y1, and z minus z1. And that is going to be, if this is a fixed point in a plane, and this is a point, any point in the plane, we have this vector, which must be, this vector must be in the plane. Vector in plane. So we can say we'll have the vector n be a normal vector to the plane. So that means that the vector n is perpendicular to the plane. So now we have, this will basically describe all the points in a three-dimensional area that are in a plane. So we basically have, it's going to look like this somewhat. We have in our 3 dimensions, we have a plane. And of course, this extends on out for infinity in every to the sides. It keeps going on that way and that way and that way. But we don't, draw it that way. We keep it short. We have a fixed point. This is point P. And here, or this is P1. And here is any other point in the plane, P. So we have a vector that's going from P1 to P. And then we have a normal vector that is perpendicular to the plane, like that. So basically, every point in this plane is going to have the same normal vector, like that. So if you have this point in the plane that has any vector over here, its normal will be parallel. Another vector over here, its normal is parallel to, all the normals are parallel. So that leads us to generalize this to the equation of a plane, which is the normal dot product with P1P is equal to 0. So that means that the normal is perpendicular to P1P. So that boils down to n1 times x minus x1 plus n2 y minus y1 plus n3 z minus z1 equals 0. So this is basically writing out the dot product with n having components n1, n2, and n3. So that is basically the general form of the equation of a plane. And I think an example would help clear this up and show you a bit more on how to calculate it. So we need to write equation of plane through point 5, -2, and 4. Well, and with normal 1, 2, 3. So this is really easy. We're given the normal and we're given the point. We just have to plug it into this form. So n1 is 1 times x, this is your variable x, minus 5, that component, plus n2, which is 2, times y minus a -2, so it's plus 2, plus 3 times z minus 4 is equal to 0. So this is called the point normal form here. Because when it's in this form, we can actually find both the point and the normal vector. This is the normal vector, and this, well, this is the negative of the point. So neg of point, and this, of course, is the normal vector. So what happens if we all multiplied this out and simplified it? Well, we'd get x minus 5 plus 2y plus 4 plus 3 minus 12 is equal to 0. Minus 5 plus minus 12 is -17, plus 4 is -13. So we have x plus 2y plus, I should say 3z. 3z is equal to minus, I said 13, right? Yeah. -13 is equal to 0. So this is, after you've simplified it all out, this is called the standard form. So standard form. And this, you can only extract the vector from. This coefficient here, this coefficient here, and this coefficient. This is really just a 1. This is the normal vector. But notice we've combined all of the point components in, we no longer can extract the point out of this form. So that's basically how you'd write the equation of a plane, and I'll do a couple of practice problems in the next video.